Hello everyone and welcome to PC Retro Tech. In this week's video I'm going to be getting back to CGA game development, and if you haven't seen the previous video about this game that I've been writing, there's a link above. But basically what I did is draw a background image just by hand in a paint program, and then wrote this very simple game engine which allows you to move a little rocket ship across the bottom of the screen. It's not complete yet, of course. And at the moment you can press the left control key to fire some missiles. Now this is done with sprites, so each of these graphics here is a sprite, a little moving image, and actually the missiles are as well at the moment. And I know what you're thinking, it doesn't look very much like a CGA game. After all, those only had four pretty gaudy looking colours. They were usually magenta, cyan and white with a background colour. Red, green and yellow with a background colour, or red, white and blue with a background colour. And what I explained in the previous video is that if you change the background colour of the screen, which can be any one of 16 colours, and then dither, so alternating pixel colours, you can get the appearance of a lot more colours than just the four. So what I want to do today is make this play a little bit more like a game. So the first thing I'm going to have to do is add little hitboxes around the moving sprites for the enemies, so that when you fire a missile, there's some kind of collision detection, which then makes the enemy disappear. So that's the first thing I want to do. The second thing, of course, is to add sound effects. It's not a real game if it doesn't have sound effects. But you might be wondering, how on earth do you do that on the original PC? After all, if you spend the time with the CPU to play a sound, surely the game itself will just pause and stop while you're playing the sound. So there's some tricks and techniques that are needed for that, and I'm going to go through those today and hopefully get that implemented in this week's video. In order to explain what a hitbox is, I give to you the brand new PC Retro Tech Whiteboard. I kid you not, this thing turned up literally outside where I live a few days ago, and I saw it there and wondered what it was, and I walked across this morning to have a look, and lo and behold, it's a whiteboard. Now it's obviously pretty scummy and I'm going to have to clean it up. There's some tape on the sides and a lot of dirt and so on that's accumulated. It's been rained on a couple of times. But I've already tried it out with a non-permanent marker, and so long as I use a more or less moist sponge, it comes off no problems at all. I think it was originally designed actually for large sheets of paper. There's a clip at the top which is spring-loaded. But I don't have any large bits of paper, and it just seems wasteful anyway, given that the back of this thing's going to work just fine as a whiteboard. First things first, I've got to get this old tape off, and I'm just going to use a piece of metal, basically this old cheese grater, and see if I can lever the tape off. Well, that went more or less according to plan. Actually, as it happens, the tape was so well stuck on there that I ended up using a little too much force and scratching a little bit of the paint. But I eventually realised with a bit of isopropyl alcohol the job went a little bit easier, and I got the other two bits off without further damage. So now all I need to do is just polish it all up, and then we can use it. Well, doesn't that look the part? It's a lot shinier now. I cleaned all the cobwebs off and gave it one final coat with some of the very limited IPA that I have left, and I think it's now in a usable state. Arguably this would be better in a horizontal orientation instead of a vertical one, given the layout of the screen. But I think this will do fine for us. And the idea is that if we have some kind of sprite, it's usually not a square shape. And trying to figure out when two non-square shapes are intersecting is a very computationally demanding process. And so on very early hardware like this, it's better to use something called a hitbox. And this is basically just a box which kind of outlines the basic shape using a rectangle like this. And you'll have a similar thing for the other sprite. And instead of trying to work out whether these complex shapes are intersecting, we just try to work out whether the boxes are intersecting. Now in our case we can do it even better because we have missiles going up and enemies coming down, So we only care whether this leading edge here is intersecting with this leading edge up here. And so if we give some coordinates to this, let's say the x coordinates are going across the screen like this, usually, and typically we have the y coordinates on the screen going down like this, then we'll give coordinates x0, x1, x2, x3 for all the x coordinates of these leading edge lines. And let's say that the y coordinate of this line is y0 and the y coordinate of this line is y1. The first thing we need to do is to tell whether the missile has gone far enough yet, and this is just the condition y0 is greater than or equal to y1. If that's the case, then this line has moved past this line. But now we need to worry about the horizontal direction, and there's two conditions to check here. We need to know if this corner is inside this line segment or if this corner is inside this line segment. If either of those things are true, then we have a collision. So in other words, we'd have that x2 is between x0 and x1, or we could have that x3 is between x0 and x1. So those are the conditions. It's basically this and this. So we need the vertical distance to be less than or equal to 0, and we need that there's a collision horizontally. So I'm going to code that up. It's very, very simple to do this. We just need to store these values, basically the y values and these two x values for each sprite. And the missiles will have to have the top end. And then we are just going to make this object disappear when it's hit by a missile. And of course the missile itself will also have to disappear. So I'll code that up now, and then the game should actually start to feel a little bit more like a game. Well, that actually turned out to be less trouble to code up than I thought. So the first thing that I did is just create an array called visible, which records whether each sprite is visible or not. And I just changed the sprites so that they only display when that is set to 1. And then the only other thing that was needed is this collision detect function, which is just run every time the main loop executes. And what it does is just do this comparison that we talked about. I've changed it a little bit, I'll discuss that in a moment. But basically it just loops through all of the enemy sprites. Those are sprites 1 through 3, and for each of those it loops through each of the missile sprites to see if any of the missiles are hitting that enemy sprite. And then all it does is just compare the y coordinates as we talked about, and then it'll compare the x coordinates. Now I decided, rather than using two conditions for the x coordinate, because the missile sprites are so small, I can just tell whether the left side of the missile is greater than or equal to the left side of the enemy, and I can tell whether the right side of the missile is less than or equal to the right side of the enemy. And if that's the case, then I just set both of them to visible equals 0, so they just both disappear off the screen. Now there's a couple of things I had to get right. Obviously when the missiles go off the edge of the screen, they need to become visible again so that when they reappear you can actually see them, and same with the enemies. But once I got all that right, it actually worked perfectly. So let's take a look at how it looks in the actual game. Well, everything looks pretty much the same, except that now when I fire a missile, if it happens to hit one of the objects, it will disappear. There's a couple of flaws, of course. If the object is off the top of the screen, just about to appear, and a missile goes up in that direction, it will actually destroy it before it even gets on the screen. I guess that's not a huge big deal. I don't think I'd even bother to try and fix that. Now the other thing, of course, is that this only works when you have missiles going up in a vertical direction and enemies coming down in a vertical direction. Because imagine if I were firing missiles at an angle, When the missile goes behind an object, the Y coordinate would be satisfied, and also the X coordinates would be satisfied as it moves behind the object, and then the object would disappear. So that wouldn't work very well. So we really need to have this vertical motion for this really simple approach. Later on I will have the enemies firing missiles, and they'll be fired at angles, and I'm going to need to be much more careful about the collision detection for those. But at the moment this is working great, and so the only thing missing to make this a kind of playable game experience is some kind of sound. So that's what we're going to do next. Well, how do we get sound on the PC? And I'm afraid it's really very primitive. The system clock is divided down to a frequency of 1.19318 megahertz, and it's fed into a chip called the 8253, called the Programmable Interval Timer, or PIT for short. And it has 3 counters in it, and one of those counters, number 2, is connected to the PC speaker. And all it can really do is generate a square wave at a given frequency. You put a count in the counter, and that tells you how long it has to wait before the next square wave starts. It sort of divides it into half in order to give the down, and then once it reaches the end of the count, it goes back up again and restarts. Now there's 2 other counters in there. Counter 1 is actually one we're not going to touch. That's for memory refresh. And the memory will actually lose its contents if that's not done. It's dynamic RAM, which needs updating every now and again with a refresh using DMA, and that's used for that. Counter 0 is often used for a system clock. Say DOS may use this to update the time and date. But what we're going to do is commandeer this, because although we can control the speaker directly here, we have no way to control the length of the pulse, how long the beat runs for. We need another timer for that. So one way of doing that, of course, is to use the vertical retrace of the screen to control how long beeps are, just count off a certain number of frames. But we're not going to do that. We're just going to take over counter 0, and I'm going to set it up so that it produces a pulse 60 times a second. It's not really important how often it is, but somewhere around about that frequency should be fine. And this actually produces just a single clock cycle pulse every 60th of a second if I set it up that way. And I can use that to trigger an interrupt. So the output of this can go into something called the Programmable Interrupt Controller, and that will set off IRQ0, which corresponds to interrupt 8. So we can have an interrupt on interrupt 8, which is triggered 60 times a second, and we'll just use that as a counter to determine when to start and stop pulses on the speaker. So this is the basic arrangement. So the question is, how do we access this hardware? Well, it turns out to be really easy to control all this hardware, as for everything in the PC. In fact, there are just 5 ports that we need to worry about. 3 of them are for the counters themselves, of course, and one of them is a control word to control how the counters are set up, and then the final one is the programmable peripheral interface, which we're just going to use to switch the speaker on and off. So these are 16-bit counters, and of course each port is only 8 bits on the PC, so we need to send 2 bytes to fill the counter. And so this is how the control word helps us out. First of all, SC selects which counter we want to address, and so if we have 00 in here, that's counter 0, 01 and 02. And these 2 bits here, the read-write bits, specify how we're going to fill those counters with values. So for example, if I had selected counter 0 and I had 1 in the read-write bit, that would mean that I'm just going to update the low byte of the counter with a write to this port. And if I have 2 in here, then it will update the high byte of the counter, and if I have 3 in here, it's going to expect me to do 2 writes, first for the low byte, then for the high byte. Now the mode is also interesting to us. Modes 0 and 1 are not interesting, they're basically just one-shot counters, but modes 2 and 3 are what we're going to use. So the mode 2 is the one that we're going to use for our 60th of a second pulse, which is going to drive our interrupt 8. Now basically what we do is we put a value in the counter, and it'll correspond to however many clock ticks we need for 1/60th of a second, and it just does a single cycle pulse at the end of the count and then restarts automatically and does it again. So that'll give us a clock tick which will trigger an interrupt 8 every 1/60th of a second. Mode 3 is the one that we're going to use to make the tone on the speaker. This one produces a square wave, so it starts high, and halfway through the count it drops low, and at the end of the count it goes high again. And of course it just does that over and over, and if you have the count set to a low enough value that you can actually hear the frequency, you'll hear a tone on the speaker. Now of course, to connect the counter to the speaker we need to use the programmable peripheral interface, which is on port 61H. And it turns out that if you just set the low 2 bits of this to 1s, then it'll connect the speaker up. And if you set them to 0s, it'll disconnect. It's a little bit more complicated than that because one of the bits is actually switching between the speaker and the cassette port, but it really isn't going to matter very much for our application here. Well, how are we going to do the sound effects for this game? Well, I've thought about this, and I want to have two kinds of sound. The first is a tone that will play whenever there's a missile released from the rocket ship, and we could pick something like 1000 Hertz, or we'll just pick a frequency that sounds nice. And the other thing that's going to happen is whenever there's a collision between a missile and an enemy, there'll just be random noise played. And you can get random noise just by changing the frequency really rapidly. So every 60th of a second, for example, will just change to a different frequency. And that'll just sound like a kind of static sound. Now, the way it's going to work is there'll be a counter for each of these in the game. So we're not talking about a hardware counter anymore, just a software value. And they will specify how long these sounds should play for. So for example, if I have a value of 6 in here, remember that our interrupt handler for interrupt 8 is going to be triggered 60 times a second from the hardware counters. So 60th of a second is a 10th of a second. And so that'll say that we want to play a tone for a 10th of a second. And basically what's going to happen is it's going to count down this value every tick. So every 60th of a second is 1 tick, and it'll count this down to 0. Once this reaches 0, it'll stop playing the tone. Now the tone is always going to take precedence over noise. If there's a tone that's supposed to be playing, that's going to play. But if there is no tone, if that's a value of 0, then it'll start looking in the noise counter, and for example a noise might want to sound for half a second, which would be 30 ticks. So we'd have a value of 30 in the noise counter. And so what it's going to do here is that every 60th of a second it's going to decrease this counter and change the frequency to something random. And when that reaches 0, so both of them are 0, then it's going to just turn the speaker off altogether. So how do we hook all of this up? Well, it's pretty straightforward. Remember that our hardware counters are going to be triggering an interrupt 8, 60 times a second. All we need to do is intercept that, and you remember from our keyboard video that this is done with an interrupt handler. And so an interrupt handler is just a function, just a piece of code that gets executed every time an interrupt is triggered. So in this particular case, it's just going to be a C function, and it's going to look in the tone value. If that's non-zero, play a tone. If it is 0, look in the noise value. If that's not 0, play a random frequency, and then it's just going to repeat this over and over. So everything is triggered from the ticks with the interrupt handler. So what this means is that this can all go on in the background. We don't need to touch it. It will just work automatically. The only thing that we need to do is that every time there's a missile release from the rocket ship, which is something we know about in our program, we just need to put a value of 6 in the tone counter. And every time there's a collision, we just need to put a 30 in the noise counter. And that's it. We just put those values in and everything else happens automatically behind the scenes, being triggered by these ticks from the interrupt 8. So it's really straightforward. Let's get to it and code it all up and see how it sounds. The first thing that I've done is just write a little set frequency function which will set the speaker going at a given frequency. So you just pass in, say, 1000 and it'll run it at 1000 Hertz. So the first thing it does is work out the value that's got to go into the counter, and to do that it just divides that 1.19318 megahertz by the frequency that you want, and that'll give you the count that needs to go in the counter. And if the count is 0, then it's going to switch the speaker off. So that's what this first statement does here. This is just going to set the low 2 bits of the port 61 to 0, just by ANDing the value that's there with FC. That'll set the low 2 bits to 0 and switch off the speaker. But if the count is not 0, then it's telling us that it should run the speaker at a given frequency. And to do this, we have to first of all switch the speaker on again, which is what this does. It just ORs the low 2 bits of the programmable peripheral interface with 3, and that switches the speaker back on. And these are the commands for controlling the counter. So the first one sets up the counters. This is the control word that I talked about, and we've set it up here for counter 2. We're doing the read-write mode 3, which means that it'll do 2 bytes in a row, the low then the high byte. We're setting the mode to mode 3, which is the square wave, and of course just a binary counter, so a 0 for the low bit. So that turns out to be hexadecimal OXB6. And so now all we need to do is just put the count into the counter, and it's just 2 bytes. We take first the low byte, and then we shift it by 8 bits to get the other 8 bits, and we put that into the counter. It's counter 2, so it's port 42 hexadecimal, and that's all there is to it. So it's a very, very straightforward function. One part turns the speaker off, and the other part turns it back on and puts an appropriate count into the PIT counter. So all I do now is when the program starts up, I call this function with 1000 Hertz so we can hear what it sounds like. Delay for, say, half a second, and then switch it off again by sending a count of 0. So let's listen to that and see how it sounds. Well, that sounds pretty good. It's a little bit low in frequency. I might actually use 2000 Hertz for the missiles. So now I'm going to code up the interrupt handler for the interrupt 8 and see if we can get our missile sounds and our collision sounds working. Well, once we've worked out all the theory, it's actually pretty straightforward in practice to set all this up. We already had code for hooking and unhooking an interrupt handler, so that doesn't really need to change very much. We're just using interrupt 8, of course, instead of the keyboard interrupt. The only other change here is that I'm now setting up the counter 0 in the PIT for the 1/60th of a second pulses. And so the low and high bytes of those just turn out to be these values, 174 and 77. And this sets us up for counter 0 with the mode 2, which is the one that we want for the 1/60th of a second pulse. And the only other thing we had to do is write an interrupt handler. So this is exactly the same as before. It's an interrupt function, and of course we have to end the interrupt with an output to port 20. And the rest of it is just really straightforward. It's exactly what I said. If the tone value is not 0, this is the counter, the tone counter, then set the frequency to some nice frequency. I chose 2000 Hertz in the end, and then decrement the tone counter. Otherwise, if the noise counter is not 0, set it to a random frequency, and I just set it to something random between 5000 and 10,000 Hertz, and decrement the noise counter. And if neither of them have values in and they're both 0, then just turn the speaker off. That's really all that's required. It's really primitive stuff, but it works just fine. So let's finally check out the game and see how it sounds now that we have sound effects. Now I left that starting tone in because, well, why not? And of course I had to hook it up so that when you press the button and a missile is launched, that tone counter gets set to 6, and that sets a tone off. So every time I fire a missile here, you can hear a tone, and every time there's a collision with one of these targets, there's a kind of tweeting sound, and that's the random sound. So that I just put into the collision detection function. It just sets the noise value to, I chose 20 in the end. One small problem, you'll notice that some of the enemies are disappearing at the top of the screen before they even come on, even when I'm not shooting. Let me just put some more bullets up there so that you can see that in action. So this is a little bit of a bug at the moment. Let's just see if we can make it happen. There we go, there was one, and another. So sometimes the enemies are getting destroyed because the missiles are sitting up the top of the screen out of view. So that's a little bug I'm going to need to fix at some point, but other than that, this is a more or less playable game at this point. There's no score, of course, and we want the background to scroll and lots of other things like music and cutscenes and so on. But as a basic game, it's kind of working at this point. So obviously lots more to come in later episodes, but that's all I have for this week. Hopefully you've enjoyed this look at how to do sounds on the PC speaker and how to do collision detection, or very basic collision detection on the PC. If you like this, don't forget to like and subscribe, and we'll see you in a later video. Bye! As a little postscript for those who made it this far, I actually fixed that bug where enemies were being destroyed if the bullets were sitting at the top of the screen. Basically, the answer was quite simple: just make them not visible as soon as they reach the top of the screen. And we already had the collision detection set up to ignore sprites that weren't visible. So now everything is working properly, and of course as soon as the missile comes out of the rocket ship it has to be made visible again, but this was an easy fix and now everything's working perfectly.